Alright guys, now we're going to talk about the explicit formula when we are using geometric sequences. Explicit formula, remember, is used to find the nth term or any term in the sequence. Remember, this one is the most common one because it allows us to find any term in the sequence without knowing any of the other terms. We just need to use the formula. So most of us don't want to multiply by the common ratio 25 times to find the 25th term. We want to find a formula where we can just plug in a number and find it. So remember, an explicit formula, we're going to use a sub n equals a sub 1, which is the initial term of the first term, times r raised to the n minus 1. Now we're using exponents, okay? That's the difference between an arithmetic and a geometric, is now we're using exponents because it's repeated multiplication. Before we had repeated addition, which meant we were going to have multiplication. Now we have repeated multiplication, so we have to use exponents. So the r is our common ratio. The n is the position in the sequence. Okay. The a sub 1, that's our first term. And the a sub n is the nth term or the term we are finding. So let's talk about this, okay? So we have to know the first term, we have to know the r. We can find both of those given a sequence. So here is the first sequence. I'm going to use the same one I used in the recursive formula, but still go through all the steps. Alright, so the first thing is we need to find the common ratio. 12 divided by negative 4 is negative 3. Negative 36 divided by 12 is negative 3. So our r is negative 3. Remember, we can tell that our common ratio is going to be a negative because of the alternating pattern between negatives and positives. So we have this. We need our first term, which is negative 4, and now we can write our formula, our explicit formula. So a sub n equals the first term, which is negative 4, times our common ratio, which is negative 3 raised to the n minus 1. Okay, so we're going to use that. So now let's say I want to find the 15th term of this sequence. So we would also write a sub 15. So we are going to take a sub 15 equals negative 4 times negative 3. Notice that the n is now replaced by 15, which is the position that we're trying to find. So we are also going to replace our n in the exponent with 15. So we have negative 4 times negative 3 to the 14th power. Alright, then we're going to do that in our calculator. Negative 3 to the 14th power is a big, long number. Now remember, I just made the mistake is when I put it in my calculator, I didn't use parentheses with the negative 3. So remember to do that. Remember to put parentheses around it because at 14, that would be an even number, so our answer would be positive. Then multiply it by negative 4, and you get 131,876. So a big, long number, but that's our 15th term in the sequence. Okay? So let's practice one more. So if I'm given the sequence 1, 5, 25, 125, 625, and so on, 5 divided by 1 is 5. 25 divided by 5 is 5. So our r is 5. We know our first term. We know our r value. Now we're going to write our explicit formula. A sub n equals the first term times r raised to the n minus 1 power. And then sometimes it'll go on to ask you about different terms like we did up here. You would just use this formula to plug in. And that's it for explicit formulas.